workshop and conference organized by the Department of Commerce, University of Kerala. Today, we have with us Dr. Sabuj Kumar Mandal, who is Associate Professor of IIT Madras. He completed a PhD in Economics from the Institute for Social and Economic Change at the University of Mysore. He is also the recipient of numerous awards for his academic and professional excellence. He has publishings in several journals and is an aspirant researcher. Dr. Sabuj Kumar has his own courses on NPTEL Swayam form on econometrics. He has already given us a very fruitful session the last day. We welcome you, sir, today on the session on application of qualitative response models in equity, debt, and other choices of financing. Over to you, sir.
Thank you, Bhagavati, and thank you, Viju, once again for giving me this opportunity. So I hope the audience, you have got a very fruitful sessions in these workshops, right? So this is the last session.
Yes, sir. This is the last session.
Last session. Okay. So as I said in our previous class, in the previous session, so what I will do today. Today, first I will take one data set and I will give you a hands-on demonstration using the statistical software's data to estimate how to estimate the logit and probit model. And then we will also learn how to interpret the results that we will get after estimation. Okay. And if you have any queries, please ask me in between, because today I have another meeting exactly on 7 o'clock. So I have to strictly leave by 7 or 7:05. I'm very sorry for that. So kindly ask your doubts in between when I discuss the concepts, right? So I'll be sharing the screen once again. This is this screen visible?
Yes, sir, it is visible.
Are you able to
Yes, sir, it is visible.
Yeah. So this is basically the data software that we are going to deal with. And what we'll do, we will estimate one model using a particular data set. And in this data set, let me take you to the data set. This data is basically on look at this data. This data is basically on married women's labor force participation. So that means after marriage, whether a particular woman will participate in the labor force or not. That is why the dependent variable here is INLF, in labor force, right? In labor force, and which is a binary variable. If the woman has participated in the labor force, then we'll take the value 1. And if the woman has not participated in the labor force, then we'll put 0. All right. So the same example, the structure is same. So whether it is women's labor force participation or firms' way of financing, everywhere the basic structure is basically same. So if you understand the model by this example, you can apply the same technique wherever you want. There is absolutely no problem, right? So what we'll do, we will try to understand what are the factors that basically determine whether a married woman will participate in the labor force or not. And for example, for simplicity's sake, we will take only 3 to 4 explanatory variables. Let us say that the married woman's age, what is the level of education, then how many kids below 6 years of age that particular married woman is having, because as you know, if the woman has more number of kids, then it would be very difficult to participate in the labor force. Then we'll also take what is the husband's level of education. We may hypothesize a positive or negative relationship. More the education of the husband, more likely would be the woman in the participating in labor force. It could be other way around also. And also husband wage, how much the husband is earning. If the husband is already earning sufficient amount, then probably the married woman may not participate in the labor force. And these are the couple of variables that we hypothesize as a determinant of women labor force participation. And then what we have to do, in this box, look at this box. This is called command box. Here we have to put the command. And the command for estimating a logit model is very simple. The first thing we have to write is logit, then the dependent variable in labor force, and then one by one you have to introduce your independent variables. So let us say this is age, education of the married woman, and then number of kids less than 6 years of age, and then husband's education and husband's wage. So these are the variables. So one thing you have to keep in mind that we need to introduce the variable here in the same way they are introduced in the data set. So you should not make any mistake in writing the variable. So this is the command. First thing is logit, then the dependent variable, and then the set of independent variables. So if you specify and after that you have to put enter. Now this is the result. This is the results data is giving you. Now from this result, what we need to understand is basically how to interpret the coefficients, right? How to interpret the coefficient. Now, those who are having a basic understanding on standard econometric models, I will take one or two from the audience and I will request them to interpret the coefficient. For example, let's say age has a negative coefficient which is significant also. So how do you interpret this coefficient? Anyone from the audience?
So that means, sir, can I answer, sir? So that means, sir, age
Yes, please.
Yes, sir. Sir, good evening. That means age,
Yeah.
the more the higher the age, it is negatively influence my dependent variable, that is the labor force. That means higher the age, it is less chance of participation in labor force. That I mean that.
But thank you, Mr. Devi Prasad. But you are not using this particular coefficient value. Minus
that is
0.05.
that is 1 unit of change will happen in dependent variable by changing on the 0.05 change in independent.
Can you repeat once again? Instead of dependent on independent, I have already specified my dependent variable. I have also specified my
that means
independent
I'm saying
variable.
very simple, 0.05 change in my age factor is influencing my participation, the likelihood participation in labor. That's what I'm saying.
Okay, anyone else? Apart from Mr. Devi Prasad, anyone else? Those who already have some kind of understanding in econometrics, kindly go ahead. Anyone else from the audience? If you share your understanding, that would be better actually. Like the way Mr. Devi Prasad also shared. No one wants to share anything. So that means Mr. Devi Prasad is the only person in the audience who had experience in econometrics, previous understanding, and all others are new. No one is speaking anything. Why? Please share your views. This is a simple econometric model I have estimated. You might have explained or interpreted this coefficient previously also. So based on your previous knowledge, you can simply interpret this coefficient. I just want another 1 or 2 responses from the audience.
It's also statistically significant. That means it definitely have a impact. Age has an impact on the labor force.
That is all. That is all right. But I want another 1 or 2 more interpretations from the audience. Okay, since no one is interested to share, so let me tell you what exactly is the interpretation.
We can say it is positive and statistically significant, but the magnitude of effect is very.
Magnitude of the coefficient.
Hello.
Yeah.
Yes, sir. I'm Rajini here.
Yes,
Hello.
Rajni.
Yeah,
Yes, Rajni. Please go
I
ahead.
can see all other variables are negatively influencing on dependent variable,
Why are you thinking about all other variables? I'm asking to
age.
concentrate on the age.
Yeah, age is negatively influencing on dependent variable.
That is what Mr. Devi Prasad has already said. I'm asking anyone to use this specific value and then interpret.
It is 0.5 to 56% is change. The change in age, that 1% change in age, negatively
Yes.
influencing on dependent variable to 0.5, 0.05.
Okay, fine.
Is it?
That's all. That's enough. That's
Okay,
enough.
sir. Thank you.
Now, thank you for sharing your views. Now, why I asked you to interpret this coefficient? Because that is the common mistake what we make while interpreting the logic or probit type of model immediately after estimation. See, when we estimate a standard model, then these coefficients are direct marginal effects. So that means in case of a standard model which we estimate by OLS, where our model where our model is y equals to alpha plus beta x, then the interpretation of beta is exactly the same way what you have interpreted. That means for 1 unit change in, let's say, age, women's labor force participation, probability of women labor force participation goes down by this much unit. Okay, and you can use log or percentage interpretation if both the sides, if you have taken log, all independent variables and the dependent variable both should be expressed in log, otherwise we cannot use the percentage interpretation. You have to clearly keep in mind. So percentage interpretation is as good as taking the elasticity interpretation, and elasticity interpretation is valid if and only if you have a double log model. That means dependent variable and all other independent variables are expressed in terms of logarithm. If that is not the case, then we cannot interpret this as a percentage change. In this model, we have not taken age, education, and other variables in logarithmic form. That is why we cannot use the percentage interpretation. Now, if I say that for a unit change in age, probability of labor force participation goes down by this much unit, that interpretation is also wrong, because if you take that interpretation, that means you are taking this value as a direct marginal effect. Now, why this interpretation is wrong? See, when I introduced the model, we said that in logic model, probability Pi is expressed as 1 by 1 plus e to the power minus alpha plus beta xi. So that means what do you want here? You want, if you do a simple mathematics, those who are familiar with mathematics, the interpretation what we want here is differentiating Pi with respect to xi. So that means delta Pi, delta xi. Is that correct? So partial differentiation of the probability function with respect to x1, x2, x3, that means age, education, and all these things. Now you can check clearly by doing simple mathematics that if you differentiate Pi function with respect to age or x, that is not equals to beta. Okay, since Pi equals to 1 by 1 plus e to the power minus alpha plus beta xi, if you differentiate Pi with respect to x, what you will get? You will get beta hat multiplied by Pi hat into 1 minus Pi hat. Pi hat means this is after estimating what is the value. If that is the case, I cannot use this value as direct marginal effect. That you have to keep in your mind very clearly. You should never forget this. How is it coming? It is coming from purely from the probability expression. Now I will pause here and ask if you have any doubt there. It's a simple mathematics I am asking. Why we cannot take this 0.05 as direct marginal effect? So you have to do the simple mathematics. you take pi equals to 1 by 1 plus e to the power minus alpha plus beta xi, differentiate pi with respect to xi. You will get beta hat into pi into 1 minus pi. And when you actually estimate the model, in place of pi, you have to use pi hat. Now, to get the marginal effect, that is why in logit and probit type of model, we need to specify a special command to get the marginal effect, and that command is mfx. mfx. So this is the command. And if you put mfx and then you see the marginal effect, that means this minus 0.01, this is actually the marginal.
Sir, your voice is breaking. I request the participants to kindly wait. Our resource person is facing some technical issues.
Dx. dy dx. Okay, am I audible? Hello.
Sir, now we are audible, sir. Now we are audible.
So which part you missed? Can you please?
Yeah, so last 2 minutes, it was a break. I mean, technical issues was there. So please
Okay,
repeat.
so I will just repeat the last 2 minutes. What I'm saying, that instead of using this value as direct marginal effect, we have to put mfx command in stata to get the marginal effect. Why this is so? Because we have to go back and see what is the model we are estimating. Our starting point of the model is pi equals to 1 by 1 plus e to the power minus alpha plus beta xi. If you want to get the marginal effect, that means you want to differentiate pi with respect to xi. And if you differentiate pi with respect to xi, what you will get? You will get beta hat into pi hat into 1 minus pi hat. So that means this measure is not a direct marginal effect. Rather, after putting mfx, what we are getting here, this is the marginal effect. This value we can take and we can interpret this as, for a unit change in age, probability of a married woman labor force participation goes down by 0.01 unit. Okay, for a unit change in age. Right now, see, stata has already calculated y, so that means stata first calculate that pi hat, and then they multiply pi hat with 1 minus pi hat. This is basically the pi hat value, and you have to take beta hat from here. This is basically the beta hat value. Okay, so del pi del xi is this multiplied by this into 1 minus of this. That is why never ever take this value as a direct marginal effect in qualitative response model. That you have to clearly keep in mind. From this model, I can only say that age and women's labor force participation, they are negatively related. As age increases, women's labor force participation becomes less likely. That is what I can say. From the education coefficient, what I can say, that as education increases, married women becomes more likely to participate in the labor force. But I cannot take this value as marginal effect. What is the marginal effect? Marginal effect is here. For a unit change in education, probability of a married woman's labor force participation increases by 0.06 unit. Similarly, all other coefficients you have to take only to see whether there is positive relation or negative relation with married women's participation. And the second table, this table is specifically giving you the marginal effect. That's all. Now, once you estimate the model, now the first thing that comes to our mind, how best is the model as far as the goodness of it is concerned? In our previous class, we were discussing that while in the standard model, we discuss or we examine the goodness of fit by R square. The R square concept is not at all valid in this model. What we need to do, we need to have a similar concept. Look at here. They have introduced a model, a measure called pseudo R square. And how is this pseudo R square calculated? It is calculated as, you may kindly write it down in your notebook. So this pseudo R square, yeah, pseudo, yes. Are you asking anything? Hello. I'm saying you may kindly write down the pseudo R square measure. What I'm saying now, the pseudo R square equals to 1 minus in the numerator there would be log likelihood unrestricted, and in the denominator there would be log likelihood restricted. That is all. 1 minus a fraction for which the numerator is log likelihood unrestricted and denominator would be log likelihood restricted. Now what is log likelihood unrestricted and what is log likelihood restricted? Log likelihood unrestricted means that likelihood value in which we have introduced all the explanatory variables. So that is why here the unrestricted log likelihood value is this minus 459.06. And what is the restricted? Restricted is this one, which is corresponding to iteration 0. So minus 514. Why this is called restricted? Because we have put a restriction over here that all the coefficients are simultaneously equals to 0. Okay, so compared to that scenario, when I introduce this 5 number of independent variable as explanatory variable, or how much I get as improvement. So that is why restricted and unrestricted likelihood values are calculated to compute my pseudo R square. If you take this value as log likelihood unrestricted, if you take this value as log likelihood restricted and use the formula 1 minus log likelihood unrestricted divided by log likelihood restricted, you will get exactly this value. And this value is called pseudo R square. Okay, this is the value 0.10. Right? You can get another prediction, another R square value, which is count R square, following the technique what we have discussed in our previous class. Okay. Now, apart from the pseudo R square, we need to also see the overall significance of the model. Overall significance of the model. See here, when we estimate a standard econometric model, here immediately after estimation, you will see F statistic, because F statistic gives you the overall significance of the model in standard econometric model. But in case of qualitative response model, that F statistic is not available. Rather, what data will supply you one log likelihood ratio statistic or likelihood ratio statistic. How is that defined? That is again defined as 2 into, you can again write it down, 2 into log likelihood unrestricted minus log likelihood restricted. Very simple formula. 2 within the bracket log likelihood unrestricted minus log likelihood restricted. So if you apply that formula, you will get this value 111.65. And that log likelihood ratio follows a chi-square distribution with degrees of freedom equals to number of explanatory variable in the unrestricted model. So in the unrestricted model, how many variables you have included? 1, 2, 3, 4, 5. So that is why chi-square will follow 5 degrees of freedom. And look at here, probability greater than chi-square, this is actually the p-value. Since the p-value is 0.0000, we can say that LR chi-square is highly significant. Lower the p-value, higher is the level of significance. We can say that LR square chi-square is significant at 1% level. So that means the model is overall significant. That is the difference between qualitative response model and the standard econometric model. In standard econometric model, it is given by F statistic, the overall significance. Here it is given by LR chi-square. Likelihood ratio statistic, which follows a chi-square distribution with 5 degrees of freedom, because we have 5 explanatory variable here. So that means instead of relying more on pseudo R square, because R square concept is not having a straightforward interpretation in this context, what we should look at is actually the overall significance of the model. So the model is overall significant, and then we have variables like age, education, number of kids, and husband's wage as significant variable. Husband education is not significantly affecting a married woman's labor force participation. That is what I am saying. I will give you a pause again, and you may kindly ask if you have any doubt in understanding these statistical measures. Do you have any doubt? How to estimate the model, logit model, and how to interpret the coefficient? Please ask me if you have any doubt.
No, sir, it's clear. It's
Okay.
nicely explained.
So,
Okay. Yeah.
Sir, I have a doubt.
Yeah, please, Ankita.
Sir, can you please explain once again like difference between these coefficients values and the marginal values? I'm just a bit confusion regarding this.
Okay, what I'm saying, when you estimate a model in standard econometric model, the equation is y equals to alpha plus beta x, right? Y equals to alpha plus beta x. If you apply simple partial differentiation, del y del x equals to beta. Very simple, y equals to alpha plus beta x. Just partially differentiate y, you will immediately get beta. That is why we can take the beta as direct measure of marginal effect in standard econometric model. But in case of qualitative response model, what is our equation? Our equation is pi equals to 1 by 1 plus e to the power minus alpha plus beta xi. In that context, if you differentiate the dependent variable pi with respect to xi, that means delta pi delta xi equals to beta hat into pi hat into 1 minus pi hat, instead of being only beta hat. That means we should multiply pi hat with 1 minus pi hat with the beta hat. What is pi hat? Pi hat is basically this value. That means after estimating the logit model, predicted value of the dependent variable is given by 0.57. If you use this value as pi hat, then you can easily calculate taking this value as your beta hat. Take this as beta hat, take this as pi hat, and use the formula beta hat into pi hat into 1 minus pi hat, you will get this value. That is what is called marginal effect. Is this clear, Ankita?
Yes, sir.
Yeah.
Thank you, sir.
You have to use little bit of mathematics, and you have to go back and see what is the model that you are estimating. So always keep in mind that in logit model, it is pi equals to 1 plus 1 by e to the power minus alpha plus beta xi. That is the model we are estimating, not y equals to alpha plus beta xi. Okay. So if you don't have any other doubts from this estimation part, then what I will do, I will share another file where actually I will take some examples from the finance literature. Okay, so let me clear this window. I will no longer use data. I will take only a couple of results from finance literature to show you what is the application of this type of qualitative response model in finance. And if you want to estimate profit, then again same concept. Instead of logit, you have to just put profit. So I'll just show you PROBIT profit. Then other command is same in labor force. Then age, then education, then your kids LT6, then husband's education, then husband's wage. That's it. So again you will get this one. This is the profit estimate, and again you have to use the MFX command to get this one, the marginal effect. So logit and profit, they are very simple to estimate, but you have to keep in mind when to apply logit, when to apply profit. That again depends on your data structure. If you have too many observations at the tail, then logit is better than profit. In the mid region, both are equivalent. So depending on your data structure, you have to select logit and profit. Don't select the model randomly like any other students. Okay, so I will put clear and then exit. I will exit from Stata, and now what I'll do, I will share another data, another basically file showing the PPTs. So let me take this one. So I will show you this. Sorry. So I will share again this one. So I'll go this. Is this clear? Is this clear? Is this visible?
Yes, sir, visible.
So these are the examples we already discussed yesterday. These are some of the examples. Why do some firms list their stocks in BSE while others do not? Why do some stocks pay dividends while others do not? Why do some firms go for debt financing while others go for maybe something else? And what factors affect whether countries default on their sovereign debt? I can extend this list of examples. There are n number of examples that you can think of. Why do some banks default while some others perform well? So using this logit and probability, you can actually estimate the probability of bankruptcy. Okay, probability of banks getting default. Okay, so there are so many examples that we can say. Okay, there are hundreds of examples that we can get from the finance literature where actually we can apply this logit and profit model. Okay, now interestingly, if you take banking literature, we can actually, there is a literature called distance to default. So using this technique, we can actually estimate what is the distance. So that means how close or how far a bank's position is to become a default. So fantastic. So that is called distance to default function. So there are several examples we can take from banking, finance, other disciplines where we have many applications of qualitative response model. That is why I have taken specifically this particular econometric model for our discussion. Now, this picture shows what is the problem of linear probability model, and here in the x-axis we are measuring market capitalization, and in the y-axis we are measuring the probability that the firm will pay you dividend. Now you see, as market capitalization increases, since it is a linear function, at this range, this is 0 and this is 1. At this range, if your market capitalization is here, so if you draw a perpendicular line, you will arrive at here, where the predicted probability is actually greater than 1. So that means at this level of market capitalization, the probability that a firm will give you dividend, it is more than 1, which is quite nonsensical. A probability greater than 1 does not make any sense. Similarly, if your market capitalization is very low, look at this level, and if you draw a perpendicular that will touch the line here, which shows actually negative probability of paying you dividend. That also does not make any sense. So for meaningful interpretation, our probability must lie between 0 and 1. So that is the problem of linear probability model. That is why next you take this model, logit and probit, which actually hypothesize a nonlinear relationship between the two. Nonlinear relationship between the two, market capitalization and the probability that the firm will pay dividend or not. And these two, so that means it is nicely, actually it should not touch here. It will never touch the axis. If you know the concept from mathematics, there is something called asymptotic distribution. So these will approach both the axis asymptotically, but it will never touch. Okay, it will never touch. So that is the idea. This model overcomes the problem of the linear probability model. Now, this is some example what I have taken, right? This is some example what I have taken. See here, the idea is whether the firm will go for external financing or not. Whether the firm will go for external financing or not. So, there are three alternative situations. We have estimated three models actually, depending on which particular variable is included or not included. See here, it is called deficit. This deficit variable is defined as what is your earning and what is your expenditure. Now, if your earning is more than expenditure, then you have a surplus. You don't have deficit. If your earning is less than your expenditure, then actually you will have a deficit. And borrowing from the pecking order hypothesis, so that means if you have less cash in hand, then you are likely to borrow. If you are financially so sound, if you have so much of cash in your hand, then basically you are less likely to borrow. So depending on the deficit, depending on the sign and significance of the deficit variable, we can actually determine whether pecking order hypothesis. I hope you are aware of pecking order hypothesis in finance, right? Are you aware of pecking order hypothesis? Hello? I'm asking a specific question related to finance, which is called pecking order hypothesis, whether you are aware of this hypothesis or not.
So can you say something on pecking order hypothesis? I think.
So if you are not aware of the hypothesis, see basically pecking order hypothesis says that when the firm decides about the mode of finance, then firm will first go for that mode of finance which is less costly. So it is believed that external financing is costly for the firm. So that is why as long as the firm is healthy in terms of its own financial resources, firm will not go for the external mode of financing. This is a simple model where my dependent variable is taking only two values, whether the firm has gone for external financing or not. If they have gone for external financing, then the dependent variable takes 1. If they have not gone for external financing, then that is called 0. Right? That is the simple model. So that means I have only two options open for the firm. And I am trying to explain the probability whether the firm will go for external mode of financing or not with the help of deficit. And deficit also I am dividing as positive deficit and negative positive deficit. So positive deficit means actually you really have a deficit. Negative deficit means you are actually having surplus. So here in the two models I have not included surplus. In the third model I have included the surplus. Look at this surplus. Surplus is negatively correlated, and within the bracket this is t value, which shows the variable is significant or not. So it is highly significant because the t value is 3.23. So that means more the surplus you have in your hand, you are less likely to go for external financing, which shows some kind of support for the pecking order hypothesis. Okay, pecking order hypothesis. And here the deficits are also showing some kind of negative relationship. So that means whether if you have more or less deficit, what will happen to your probability of external mode of financing, that is basically determined from this simple model. Similarly, if you have assets, what is the level of assets? So the asset is again, it is showing some kind of positive impact, but they are not significant. Okay, then what is the industry asset growth? Well, in which industry you are operating, then previous mode of financing, so on and so forth. Okay, previous mode of financing. Previous mode of financing is actually determining whether you will go for external financing or not. If you have gone it previously, then it is showing that this year also you are likely to go for external financing. Now, inclusion of these variables, you have to keep in mind, these are all coming from the finance literature. As an econometrician, I have nothing to do here. So
can I refer? Can we able to check the performance of a corporate with external financing in this model? Whether the performance of corporates means when we compare the performance with the external financing, the performance is increased with external financing or decreased with external financing. That kind of.
Yes. That you can check, but then that model won't be qualitative response model. So that is a simple model where your independent variable will become binary, because in that case you will simply measure performance, let's say, by profitability. So your dependent variable is profitability or return on asset or anything. Your dependent variable is not binary. Then in the set of independent variable, you have mode of financing which will take two values, 1 and 0. So it will act like a standard dummy variable model. Okay. So the context what I am discussing here, you have asked an interesting question. So that means the question what you raised, in that case, if you want to see whether the mode of financing has anything to do with corporate performance you can measure. There are several variables. You can measure profit efficiency, you can measure profitability, you can measure simple efficiency, you can measure return on asset, you can measure by Tobin-Skew ratio. There are n number of measures that you can use to measure corporate performance. Then in the right hand side, you will have the firm's age, the firm's R&D, the firm's corporate structure, the firm's board structure. Then within the set of explanatory variable, you would like to include one variable which is mode of finance. So that will take 1 if the firm has gone for external financing, that will take 0 if the firm has not gone for external financing. But that will be a standard dummy variable model, not the probit or logic kind of context what we are discussing here.
Can I intervene? So if I convert that, suppose my return on assets or I take any variable, then I said if a positive performance, then 1, negative performance 0, convert it to binary, then I can use a logic model.
That you can use, but you must provide some logic. Why you have measured that particular return on asset as 1, that particular measured as 0. So that should be acceptable to all. For example, you are saying return on asset, if it is more than 5 lakhs, then it is 1, less than 5 lakhs, it is 0. Then immediately the referee will ask you the question, why you have taken 5 lakhs as a benchmark category? What is the justification that you can provide for selecting 5 lakhs return on asset as the threshold? If you have a justification from the existing literature, or if you have a justification of your own, then it is absolutely fine. Econometrics should not be used just for the sake of use. Econometrics is basically a tool. Your major emphasis should be given on finance. So what is the finance literature that you are discussing? What is the finance literature that you have consulted before highlighting a particular research question? Is this clear?
Yes, sir.
Yeah. As far as methodology is concerned, absolutely no problem. You can define that with your dependent variable and you can apply logic or probit model. But what I am saying, a referee will ask you a question. Okay, you have applied a logic model using a threshold point 5 lakhs of our return on asset. What is the justification for that?
Sir, one doubt, please. Sir, regarding choice of this logit and profit model, then we have to put the data set of dependent variable only in the tail side. Is it? Am I able to clear it?
No, you have nothing to do with your data. You have no control over data. You first collect the data, and then you see how many percentage of your sample are taking external finance. If it is 10%, that means you are at the lower end.
Percentage of sample means that dependent variable, or what you mean by that percentage of samples?
That is what I am saying. Percentage of firms gone for external financing, which is the dependent variable.
Yes, okay, that's right.
Yeah. Similarly, if it happens that only 10% of firms have gone for external mode of financing, then you are at the lower tail. It may also happen that 90% of your firms, they have gone for external financing. That means you are at the upper tail. In both the cases, we must apply a logic model, because logic model has a flatter tail, which is better to capture the tail than the profit. But if it so happens that 40% of the firms gone for external financing, another 60% of the firm not gone for external financing, you are actually not in the tail, but you are in the mid region, where you can actually apply both logit and profit.
It's clear, sir. It's absolutely clear. Thank you, sir.
Yeah. Now, okay. Sorry. This is another equation. This is multinomial logic. This is multinomial logic, and here why I am using multinomial logic, because now I have extended my dependent variable into multiple options. So external financing can also be of many types, as I discussed yesterday. You may go for public issuing public bond, you may go for issuing public equity or private equity, or you may not at all gone for external financing. So if you take not going for external financing as benchmark category 0, then going for debt is 1, going for equity is 2, going for public bond is let's say 3, going for private equity it's a 4. So multiple such options. Okay, so in this example we have taken that many options open for in front of the firms. That is why this model has now become multinomial logic. And in multinomial logic, always we have to take one category as base category. So what we will be estimating here? We will be estimating probability of going for a particular mode of finance compared to the base category. If your base category is internal finance, then I have to interpret the coefficient as, for example, let's say unleveraged Z score. What is Z score? I will explain later. So this Z score is basically, those who are from the finance literature, you might have heard about Altman Z score, which basically determine the financial health of the company, which is used as an indicator of risk. What is the risk? Whether the firm is high risk firm or low risk firm. Generally, a high risk firm will only go for the costliest mode of finance. That means high risk firm only will issue equity in the market, because they know that they have no other option open but to go for equity mode of finance. So that is the last option. So if you are highly risk firm, you will go for this. So from here, from this Altman Z score, then what I can this is equity equation. Let's say this is bond equation. So that means there are 3 modes of finance: internal finance, equity finance, and bond finance. How I will interpret this coefficient? I will interpret the coefficient as, since the coefficient attached with the Z score is positive, I will say that as Z score increases, that means as financial health increases, probability that the firm will go for equity form finance compared to internal finance is actually increases. That means that is positive. That means that shows no support for the pecking order hypothesis, because pecking order hypothesis says if your risk increases, actually you should go for That is, yeah, it is correct. Actually, it is showing evidence in support of pecking order hypothesis. As your risk increases, you are more likely to go for equity finance. Okay, more likely to go for equity finance. But this variable is also significant. That means as risk increases, bond finance, that means mode of finance through issuing bond compared to internal finance is also increasing. And we assume that bond is little safer than issuing equity in the market. Okay, issuing equity in the market. Likewise, we have debt here. What happens to firms' probability of going for external finance compared to the base category? That is given by this variable 1.72. It shows as debt increases, then the firm is more likely to go for equity finance. Likewise, R&D, whether you have any venture back, what is the age of the firm, then what is the plant, property and equipment, what is industry growth, what is non-financial equity issuance, what is the assets, so on and so forth. It shows that as asset increases, you are less likely to go for equity finance, but it is not significant. But in case of bond equation, as asset increases, you are more likely to go for issuing bonds. That means compared to internal source of finance. Now, what you have to do, you have to take all this result, get the interpretation, and then you have to match with the finance literature. You have to explain why this is happening, taking help from the finance literature. You cannot simply say this variable is significant, that variable is not significant. That is not financial research. That is a bad way of doing research. What is the good way of doing research? You take the value, interpret the coefficient, and see whether your coefficients are giving expected signs. So that means whether the signs are in line with the finance theory. If you cannot explain your coefficient in that way, then people will always ask you hundreds of questions why this is so. And there is absolutely no meaning in doing econometric analysis if you cannot back your result with proper theory from the finance literature. Then this is another model. This is again basically, this is a ordered profit model, another variant of profit model. I am so sorry I could not discuss the theoretical discussion because time was very limited, but I can tell you only the context where we can actually apply ordered profit model. In ordered profit model, basically all the options are ordered. That means we assign some kind of value judgment. For example, when you fill the feedback form, many a time you come across a specific type of question, then they will ask you whether you agree, strongly agree, not at all agree, like that. So strongly agree is higher than agree, agree is again higher than not at all agree, right? So that means these options are attached with some value. For example, when you go for equity finance, bond finance, and internal finance, if you believe that internal finance is better than bond finance and bond finance is better than equity finance, then that is the way I have actually ordered my dependent variable. Is that clear? So I will always attach some kind of value judgment. What kind of value judgment you will attach, that up to you. For example, let's say there are 3 modes of travel. One is by bus, another one is by train, and another one is by flight. For a particular individual, if the particular individual believes the flight mode of travel is better than train, and train mode of travel is better than bus, and bus mode of travel is better than taking a bike, then that is the way you have ordered. That does not mean that in the sample everybody will have same type of ordering. So given a sample, I will then try to understand why different firms they have ordered their mode of financing in different ways. But that specific information you must collect from the sample. When you are working with secondary data, it is difficult to get that type of ordering. Anyway, here It is an ordered profit model, and then in ordered profit, what we need to do is to understand why a particular individual, why a particular firm is thinking equity mode of finance is better than, let's say, bond mode of finance. So that is what is explained here. So with this, basically, I am closing my discussion here. As I said, I have another meeting on 7 o'clock, but I still have another 5 to 6 minutes to spend. Kindly ask you if you have any doubt in this particular context, that models we have explained and the examples what we have discussed.
Sir, ordered profit model or ordinal logistic regression are same or something different?
No, same only.
Okay.
You have only ordering your dependent variable. That is little advanced level model. So it is not simple logical profit. Actually, in the class of qualitative response model, there are many models. I can offer a full semester itself. You can understand. I can offer a full semester only on this topic. Forget about econometrics, only on this topic, application of qualitative response model in finance. That would be a full semester. So you can understand how vast is the topic is. So let us concentrate our discussion only in logit, probit, and multinomial logit. For that,
in strata multinomial, the same command will be used?
No, the command is mlogit. Instead of logit, we have to use mlogit. Okay. And each and every command is actually available on Google. Getting the command and estimating the model is not a great deal. But what is difficult is to understand the theoretical stuff of econometrics. For example, we were discussing why the coefficients are not direct measure of marginal effect. That is not explained in Stata. For that, we need to read the textbook or we need to discuss with someone who is actually involved in this subject.
It's a question in the chat box. Can you able to read?
If you have any other questions, can you please ask?
It's a question in the chat box.
I'm not able to see the. Can anyone help me?
Yes, sir, I'll help you by reading the question. The question goes like this. Should we be able to test the heteroscedasticity, autocorrelation, multicollinearity, normality of the error, etc. in probit logic models?
Exactly. Yes, very good
How
question.
to test it using data?
No, the data I have not discussed, as I told you, since the time was very limited. But heteroscedasticity is very easy to check. For any model, you can just put VCE robust. After putting the command VCE robust, you will get the heteroscedasticity consistent standard error. Okay, absolutely no problem. Autocorrelation, we may not have to be bothered so much because here we are mostly working with cross-sectional data. If you work with panel data, then yes, of course, you have to check autocorrelation also by same method called Darby-Watson and other methods. There are advanced methods available, but I'm sorry I could not discuss the theory portion, and something which I don't discuss in theory, I feel little uncomfortable to show you how to get the result in data. But your question is quite valid. All those tests are actually you need to perform. If you understand basic problems of heteroscedasticity, autocorrelation, multicollinearity is also easy to check. For multicollinearity, you can simply put VIF command or that will give you what is the, is there any variable that is creating multicollinearity or not. So before estimating, when you specify the data set, that time itself, without putting any command, in the command box, you just put CORR command. CORR. If you put CORR, then Stata will give you the inter-variable correlation. So you can easily understand whether there is any high degree of intercorrelation among those explanatory variables. Is this clear? May not be very clear because I'm not able to discuss in detail, because first my nature is I will first discuss the theory and then only I will discuss the empirical part of it.
Yes, sir. Thank you for the clarification.
Yeah.
So participants, any more questions, please ask.
If you have a doubt, instead of putting in chat box, please introduce yourself and ask the question so that I can get it. So the previous participant, can please introduce yourself?
Host, please mute Dr. Muhammad.
Yes, sir. Done.
Okay.
Yeah. So any other questions?
So if you have no other question, we can conclude.
Yeah. We can conclude the session. I'm sorry I spent very little time, as I told you, this is a vast topic. So I could not justify the topic much, for which I'm really sorry. In future, if we have more time, so I will give more justification for the topic itself, because it's really not possible to explain things in 2 hours. I'm very sorry for that. So in future, probably we may have another occasion where we can discuss in detail about this qualitative response model. Yeah.
Yes, sir. Sure, we can have more offline sessions with you in future. So
Yeah.
university will invite you for that. So thank you so much for the wonderful lecture. Today we have more integrated, that these sections were more integrated with the finance topics. Now the participants have got some ideas in which areas in which the probit logic model can be applied. So you can extend with this and you can you have got a value additions of this session and can be used for your research and making papers and all. So thank you so much, sir, for the wonderful lecture in this session.
Thank you, Biju, for the opportunity once again.
Yeah.
Thank you, sir. It's my privilege and honor to extend my sincere gratitude to Dr. Sabuj Kumar Mandal. You have definitely given us an interactive session. In spite of your busy schedule, we are grateful to you, sir, for spending your valuable time for this session. It was, in fact, very enriching session, and I'm definitely sure that the participants have gained immense knowledge from you, sir. On behalf of the Department of Commerce, University of Kerala, and all the delegates present here, we thank you, sir.
Thank you, Bhagavati. I just have one request. For 1 or 2 seconds, you have spoken so much about me. I just want to see you. Just 1 second, switch on your video. Bhagavati?
Yeah, sure, sir. She is with me. I mean, we are all sitting in in our room.
Okay.
Yeah.
Okay.
So she is an MPhil scholar of our department.
Oh, okay. Very good. Okay.
Sir, hope I am visible.
Yeah. Now you are visible. So what is your research topic, Bhagavati?
Sir, now I'm doing my topic on reverse logistics.
Reverse logistics. Okay. Fantastic. So that is related more on supply chain, right?
Yes, sir. It's on supply chain.
Yeah, very good. So we have applications in supply chain also. You can use this type of models in supply chain as well. Thank you.
Yes, sir.
Thank you.
Sir.
Okay.
Thank you so much.
We are concluding our session here.
Thank you, sir. You may leave. Yeah. So we can have validity session right now. Thank you, sir. Thank you so much.
Okay. Thank you. Okay. Good night.
Good night. Okay. Keep in touch, sir.
Yeah.
So that's an end to our 10th session workshop organized by the Department of Commerce, University of Kerala. And today we had with us Dr. Sabuj Kumar Mandal, and I'm sure that all of you had an enriching session. We are now moving on to our validatory session.